In this lesson, we're going to talk about determinants. We use determinants to help us solve systems of equations. So in the past, in the Unit 0, we talked about solving systems graphically, solving them using substitution and elimination. So now we're going to introduce another way to solve them using Cramer's rule. So the first thing, determinants are only associated with square matrices. So if you had a 2 by 2, a 3 by 3, a 4 by 4, you can find a determinant. If you add something other than that, say like a 1 by 2, 2 by 3, they do not have determinants. So here's a little example of how you determine the determinant. So DET stands for the determinant, and same thing, these vertical lines that kind of look like absolute value symbols, that's also the determinant symbol. So you're going to take your entries, and you see here they're color-coded. You have A, B, C, and D. The main diagonal, which is A and D, that's what we call the main diagonal in a matrix. You're going to multiply A times D, that's what they show here in blue, and then you're going to multiply B times C, and you're going to subtract those values, and that gives you the determinant. So now for the 3 by 3, this is pretty important. You want to repeat the first two columns, and you're going to just rewrite the first two columns. So A, D, and G was rewritten here, and B, E, and H also rewritten. So again, following the main diagonal, which is A, E, and I, so you're going to multiply down your main diagonal, that's this first term right here, and you're going to multiply the next diagonal, which is B, F, and G, and then your third diagonal here, C, D, and H, you're going to multiply, and you're going to add all those numbers together. So multiply down your main diagonal, and then you're going to multiply on the other diagonals. So multiply, 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 you'll add all those together, and then you'll subtract those two values. So if I wanted to find the determinant in number 1, so 5, -2, 1, and 3, I'm going to take the numbers on the main diagonal, 5 times 3, and I'm going to take the other two numbers, 1 times -2, and you're going to subtract those values. So you'll have 15 plus 2, which is equal to 17. So that's your determinant. So for number 2, you're going to multiply 0 times 4, and 3 times -1. You'll subtract those values, so 0 plus 3 is 3. So for number 3, I'm going to go ahead and make this a little bit bigger because I have to rewrite my values of my first two columns next to it. So I'm going to write 2, -2, and 1, -1, 0, and 2. So the first two columns I just rewrote outside of this matrix. So I'm going to, on my main diagonal, let me use a different color. On my main diagonal, 0, 2, 2, 4, and 2, 0, and 4, and then I have -1, 1, and 1, and 3, -2, and 2. So I'm going to multiply 2 times 0 times 4, and -1 times 1 times 1, and 3 times -2 times 2, and that will give me 0 plus -1 plus, let's see, -12. And then I end up having to subtract, and I want to do my other ones. So we have 1 times 0 times 2. Oop, missed the 3 there. That should have been to the 3. 1 times 0 times 3. And 2 times 1 times 2. And then 4, -2, and 1. So let's see, that gives us 0 plus 4 plus 8. We'll subtract those from each other. So you'll have negative 13 minus 12, so negative 25. Go ahead and try number 4. Again, when you come back, I'll have the answer down below. Okay, so here I ended up with a determinant of 116, and you can see my work. I tried to color code it. In red was your main diagonal, and in orange was the other diagonals, and then I subtracted those. I get 116. I'm going to go ahead and set this up as a system of equations as a matrix. So again, this first matrix is going to be what we call the coefficient matrix, because it's going to contain the coefficients of our x's and y's. So negative 2, negative 4, 1, and 5 are going to be written as a 2 by 2 matrix, looking like that. And then our second matrix would contain your x and your y, your variables. It's called the variable matrix. And then on the other side, we have the 10 and the 2. So this is what that systems of equations would look like in a matrix form. Now you would get the same answer if you were to multiply the first row and the first column. So negative 2 times x is right here, negative 4 times y, and you add them together. That's where this came from. So for number 6, your coefficient matrix, 5, 7, negative 3, negative 1. Your coefficient or your variable matrix, x and y. And then we have our solution over here on the right, 1 and 3. And looking at Cramer's rule will help us determine what x and y are without actually having to do elimination or substitution or have to graph it. So here in each of them we have the determinant of the coefficient matrix, which is A. Let A be the coefficient matrix. And then in the numerator we're finding determinants. You'll notice here when we're finding x, the E and the F are what we had over here on the other side of the equation. They will substitute in place of the coefficient of x's. So instead of A and C, we're going to replace those with E and F. And B and D, the coefficients of y, will stay in that determinant matrix. And then over here for y, vice versa, you're going to replace your coefficients B and D with E and F. And then the x's will stay the same that time. So that's how pretty much Cramer's rule works. So the first thing I'm going to do is I'm going to find the determinant of A, because I think it's easier to find that first since you need to know that. So the determinant of A, that's your coefficient matrix. So 3, 1, negative 2, and 4. So the determinant here would be 12 minus, so again that was 3 times 4, minus 1 times negative 2. So 12 minus a negative 2, so your determinant is 14. So that would be the denominator of each of these that we have to find. So the first thing I'm going to find is x. I know the denominator is going to be 14. And then again for Cramer's rule, since we're finding x, instead of the 3 and the 1, I'm going to put 22 and negative 2 down that column. And then I'm going to keep the negative 2 and the 4 that are next to the y, the coefficient of the y's. So finding the determinant here, we would have 88 minus 4. 88 minus 4 is 84. 84 divided by 14 is 6. So your x value would be 6. And then to find y, again, our denominator again is 14. Remember, when we're finding y, we're now going to substitute the coefficient of y. So instead of negative 2 and 4, we're going to put 22 and negative 2 in that column. But we will keep the 3 and the 1 this time. So 3 times negative 2 minus 1 times 22. So So you get negative 28 divided by 14, which is negative 2. So the solution to this would be the x value is 6 and the y value is negative 2. We do use them as an ordered pair when we write the solutions. For number 8, finding the determinant of A first, the coefficient matrix. So 3, 4, 2, and 1. Again, are your coefficients from over here, 3, 4, 2, 1. That would give you 3 minus 8. So the determinant of A is negative 5, so that will be the denominator of each of our variables. So let's find x first. Again, we know the denominator is negative 5. And in Cramer's rule, it says instead of 3 and 2 in the first column, I'm going to put 2 and 3. But the 4 and the 1 will stay put. So 2 minus 12. 2 minus 12 is negative 10. Divided by negative 5 is 2. And the y value, keeping the negative 5 in the denominator. So instead of the 4 and the 1 in my coefficient matrix, I'm going to put a 2 and a 3. But the 3 and the 2 that were the coefficients of x will stay in that column. So 9 minus 4. So 5 divided by negative 5, or negative 1. So the ordered pair to this would be 2, negative 1. And number 9, go ahead and try to do number 9 on your own and see if you have the right answer when you come back. And for this one, I ended up with an ordered pair of 4, 2 as your point of intersection of these two lines.